Hey everybody, it's Miss Austin, and I'm going to be going over the Unit 4, Lesson 14 practice problems. Today we learned about solving exponential equations mentally. You can use a calculator at the end to double check, but we're trying to do it mentally. Number one, solve each equation without using a calculator. Some solutions will need to be expressed using log notation. So today, the strategy, right? I mean, I know my powers of 10, but I got to get 10 alone before I can think that through. So I'm going to divide both sides by 4. 10 to the x is 100,000. Now, 10 to what power makes 100,000? I don't know, you can count the zeros, right? 1, 2, 3, 4, 5. Right? And we can check that when we're done. Let's just check. 10 to the 5th, 100,000. Okay, here, it's already alone. 10 to the what power will make 1? I know 10 to the 0 makes 1. So this needs to be equal to 0. So n plus 1 needs to be 0. You can either do that mentally or you can do the math. N needs to be negative 1. Because if I put a negative 1 in there, negative 1 plus 1 makes 0, and 10 to the 0 is 1. Now, letter C. I know, right, if I cover that power up for a second, 10, that's 6 zeros, a million. 10 to the 6th makes a million. So this, let me write out what I know. I know that's what I should have. So 3n needs to be 6. I know some of you already know the answer right now. I'll do out the math, so n has to be 2. I put a 2 in there, 3 times 2 is 6, 10 to the 6th is a million. All right, now letter D, we finally are getting to one. 10 to what power makes 725? That's not an integer, okay? So this is one where I'd want to write it as a log, right? So this would be log base 10 of 725 is the power I'm looking for. That is the answer. I could get that on my calculator or in a table if I wanted. Let's practice typing that in. That's log base 10. So it's just your common log, log 725. Is it 725? Yeah. So about 2.86. And then just to make sure it makes sense, like put that in. What's 10 to the 2.86? About, we rounded, but you can see that it's about 725. Okay, here I've got another one, right? I cannot create a log expression out of this until the base is isolated. So I've got to get rid of this 6 times, so I'm going to divide. So this is 10 to the t equals 60. 10 to what power makes 60? There's no integer power there, so I'm going to rewrite it as a log. Log base 10 of 60 is the answer. So I could check this on my or actually evaluate it on my calculator. Log of 60. So it's about 1.778. Let's try it. 10 to the 1.778. Yep, or I just checked it in this one. Okay. All right, number 2, solve, show your reasoning. So if I can get that 10 alone, I can think through my powers of 10. It's being multiplied by 1/4. So to get rid of 1/4, I mean, it sort of sounds confusing to divide by 1/4. So a strategy I use with fractions is I multiply by the reciprocal, which is basically just 4. So I'm going to multiply this side by 4. So I get 10 to the d plus 2 equals a 4th times 4 is 1. Now this is sort of like letter B up there. I know 10 to the 0 power makes 1. So this needs to be 0. So d plus 2 needs to be 0. So that means d needs to be negative 2. Write 2 equations, one in log form and one in exponential form, that represent the statement, the natural log of 10 is y. So they want me to write in log form and exponential. The natural log, that's the ln of 10, is y. Now how do you write that in exponential? Just to kind of remind you, natural log means log base e. right? I'm just going to write it like that. Those two are interchangeable, but maybe, you forgot what the base is here. So the base is e. So it's going to be e to the y is 10. E to the y is 10. Explain why the natural log of 1 is 0. Well, just like we just talked about here, if it helps, remember the base on the natural log is e. That's what this really says. But because this is, right, this occurs naturally, and so that's why they call it the natural log in, decaying matter and money problems. So I can see, right? So that technically means e to the 0 makes 1, which is correct. That is saying that I have to raise e to the 0 power to get 1. All right. Number 5. If the log base 10 of x is 6, what is the value of x? Explain how you know. I like to use this little counterclockwise circular motion. This is the base, this is the power, and that's the output. So this is saying 10 to the 6 is what? Well, 10 to the 6 is going to be 6 zeros. Okay? Because I know that that's the exponent I'm raising 10 to. Number 6. For each logarithmic equation, write an equivalent equation in exponential. Again, I'm going to do that little circle thing. Look, 2 to the 4th is 16. And another, keep in mind, this is the power. The answer to a logarithm is the power you're raising the base to. So this is 3 squared equals 9. 5 to the 1st equals 5. This one, 10 to the y power equals 20. 2 to the y power equals 30. Now, on all of these, they make sense, right? Because I know what they evaluate to. So I know I've done them correctly. These, right, I don't know the answers, but I have put them in the right exponential form. All right, last one, number 7. The function f is given by f of x equals e to the 0.07x power. What is the continuous growth rate? When we use e, the growth rate is right there. So the growth rate is 0.07. By what factor does f grow when the input increases by 1? So, if you think about it this way, I'm probably going to do this longer way than I need to. If I put a 0 in there, that'd be 0, and e to the 0 is 1. Okay? I'm just trying to get two values to figure out how much it increases by. Now I'm going to put a 1 in there. I'm going to use my calculator. Second e to the 0.07, hopefully times 1, it's not really, I get 1.0725. So when I increased my x by 1, by what factor did that grow? What did I multiply 1 by to get this? If you can't tell mentally what that is, you can take this and divide it by this, but it's just this number right here. Because 1.0725 divided by the number in front of it, that's the factor I grew by. Okay, I hope this helps, and I'll see you soon.